Okay, so we're going to look at another way to analyze trusses, and this is using the method of sections. And this is the method you'll want to use if you have a very large truss and you just want to find out the force in maybe a few members towards the middle of the truss, something along those lines. So this method uses the idea that if the entire system, the entire truss is in equilibrium, then any portion or any segment of that truss or system is also in equilibrium. So we kind of break it up into pieces, knowing that if the whole thing is in equilibrium, then any part also is in equilibrium. So what we do is we kind of quote-unquote cut through our members to expose the tension or compression within that member. So, for example, we just take a very simple two-force member that I have here. If I cut through that member, and I can separate it into actually two separate segments, okay, and to keep that in equilibrium, okay, the tension has to be on both sides, both on the top as well as in the cut. So, if these two force members are in equilibrium and I cut through them, I basically expose, making the internal force external, and then I can apply equilibrium equations. So the procedure on this, okay, in solving this, we kind of have an example over here of a truss, okay. First thing you should do, can do, it depends again on the system that you're looking at, is find the reaction forces, okay. And if you're not sure whether or not you can do it without, never hurts to find those. And again, that's by applying the external forces on the truss, applying equilibrium equations to figure out those reaction forces. Okay. Once you've got those reaction forces, you go ahead and you cut through the truss, and that's what this blue line AA is representing. I'm making an imaginary cut, okay, which again exposes those internal member forces and makes those external to two different segments. Okay, so when you make this cut, you want to make sure that it goes all the way through. You have to completely separate the truss, so draw a line all the way through so you can completely separate into segments. Okay, and then you don't want to cut through any more than three members because, of course, we only have three equilibrium equations that we can use to solve them. So when you make that cut, make sure you don't cut through any more than three members, otherwise you won't be able to solve it. Okay, so then what you do is you draw the free body diagram of either segment. Okay, I chose the left side here because, again, I could then solve this without dealing with the reaction forces over at D and E. Of course, I could have drawn the right side as well, and I would have had those reactions over there, okay? And I would have still had these internal forces that I could, draw in the other direction. But when I cut through, what I have is now these internal forces become external. So I have FBC, FCG, FGF, just like I had when I cut through a single member up here. Okay, and in general, what I always assume tension. Okay, that way if I get a negative answer, it becomes compression. And again, tension is going to be out of the member. That member is in tension, just like what I have here. If I cut through right there, I'm going to have tension out of the member. And that's basically what I've done. I made that cut through no more than three members, and expose those internal, making them external. So now I have a free body diagram with the one known force and then three unknown forces, which I can apply my equilibrium equations to. Okay, so I got the sum of the forces in the x, sum of the forces in the y. And in general, it's best to sum the moments about the intersection of two unknown members. So I would actually sum the moments about point C in a problem like this because both FGC and FBC go through that. I also could go about point G because FGF and FGC go through that point. You'll want to choose one of those 2 points to sum your moment about, okay, to figure out those internal forces. And of course, if you get any negative answers, assuming everything you've assumed is in tension, if you get a negative answer, then you're actually in compression. So again, all we're doing is we're cutting through these members and splitting them up and exposing those internal forces and then applying equilibrium to 1/2 of the truss that I've cut open.